So I'm Chris O'Brien. I'm a product manager here at SolarWinds. I spend a lot of my time working on our networking products. That's where that's the headspace I'm in pretty much all day long. If you look at the changes that we're seeing, this definitely has an impact on network. So we've been thinking about what that means. And really for the networking side, all of these applications end up having hybrid paths. So paths that include some component of your networking gear as well as some component of other people's networking gear, and generally many people's networking gear. So in this sort of environment, running a single application, one of these paths will, instead of going from your data center to other devices in your data center to another one of your data centers to your client across your private WAN. Instead, you're going through your data center to the public internet service providers, through to the SaaS provider, back to your data center, and so on to get all of this working. Okay, so the pathing that your traffic goes through, the critical path that your traffic goes through, has changed a lot, and there's a lot more hands in the transactions. So if you look at the tooling that we've had over the last 10 years or so, there's an assumption of privileged or administrative access to most of the gear in the transit path. So this is a problem, right? Because as we're IT guys, so we are responsible for technology services. We have our applications moving out of our data centers and into these public spaces and going through all of these different companies that become involved in the critical path for delivering that technology. But we are still responsible for that technology. So when we depend on tools that assume administrative access to function, we get in trouble. So our guys, we're losing our IT guys. We cover a lot of IT guys in terms of monitoring and management. Our IT guys were losing that visibility, but not losing the responsibility. And so we were asking ourselves, what can we do to help with that? So I'm going to show you here today a toy we've been playing with in the lab. We've got a number of really good people in our development group working on this toy in the lab. I'm going to move these guys out. We can take a look at what this actually means to us. Let's see. All right, so we'll jump on over. We call this thing NetPath. So that's what I'll be going through today. So if you think about network problems generally amount to, in terms of symptom, some user, whether that's a real user at a location or a server, accessing some application. So there's a source and a destination. And in virtually all cases, it's either slowness or broken connectivity that you're troubleshooting. So regardless of the complexity of the problem, the one thing that you usually do know is the source and the destination. So that's the entry point in NetPath to build a path. So I'll show you what that looks like. In NetPath, we call the destination a service. So we like thwack.com, our community. So I'll add a service here called Thwack. You log in through SSL on that. So we're going to do port 443 for the destination there, and we'll put in some arbitrary probing interval. From that, now that we've got our destination, you configure what we call the probe, which is the source of the transaction that you're trying to monitor, the path that you're trying to monitor. So we've got a number of options here. We can create a new one, but we'll just stick with this option that we have. So that thwack.com is starting to pull. It'll take about 5-7 minutes, depending on the probing interval you put in there. But let's jump over to an active path and see what one of them looks like. So this is connectivity over to Quest, and this is the path. So the first thing we want to do is sort of get oriented. On the left-hand side of the screen here, you have the source of this communication. And on the right-hand side, you have the destination. So the source is in our environment that's running on one of our machines in our dev box. And in this case, we're going over to to Akamai, which is hosting some content delivery, and it's content delivery network, so it's hosting some content for one of our sites. So looking through here, we have, so to get your bearings, we have software installed on the agent. That's what we deploy. There's no other software installed on this topology. So from the agent, he connects to this 10.110 private IP, that's our IP address. And then he connects to this guy. And then he gets to the public internet. So this is actually a node that's owned by SolarWinds. The routing for it is this public prefix. And it's originated by our autonomous system number. From there, we actually jump through, let me get this guy out of the way. Gets a little bit more room. We jump through Time Warner Cable, that's our ISP here. Time Warner Cable has 2 autonomous systems. We jump through both of those. That connects to XO communications. And finally, over to Quest. So Quest actually has Akamai nodes directly in their network that are serving up this content. So we can see that progress. And one of the things I'd like to highlight is, the first step in troubleshooting a problem is getting our bearings. So now we have our bearings. So let's explore a little bit here. If we pop open this guy, we can see inside Time Warner's network here we have some multipath going on. One of the things you'll notice about internet paths is they're much, much more frequently multipath. Something like 80% of internet paths include multiple paths. Time Warner has this other network that has 4 redundant nodes here. You can take a look at that. So we sort of get our bearings for what are the connections and nodes that need to be functioning for this service that is being delivered to our users to be working well for our users, because that's that's the entry point.
I might have missed it. How are you collecting that information? What's the source of this path information?
So we have an agent deployed here. We do active probing. We send traffic that looks like the application traffic, measure responses, and generate these results. So it's a lot of probing and then a lot of analysis in the background that generates this graph.
Okay, so it's a bit like traceroute.
There is a similarity with traceroute. The core of it is really that traceroute and this NetPath tool both use TTL decrementing. That's about it. We use TCP, we use a WinPCAP, we craft our own packets. So it's quite different, but the TTL decrement is something in common.
Okay. And you said, sorry, go on.
So what does that agent live on? Is that in my organization on a server or?
So if you think about the core value of networking, the value is in delivering services to users. So for us, we want you to, or we want in our labs to place agents where you have users. So in this case, it can be any Windows device. You can deploy an agent. If we were deploying it here, we'd probably deploy it in the Austin office. We'd probably deploy it in our Boulder office, sort of these different geographically dispersed areas that all depend on these services.
So agent will be required to monitor.
Agent is required on the source.
Okay.
For this.
And the only agent support today? Go ahead.
An agentless collection
Yeah.
your product can do today.
Yeah.
Okay, but this will be different.
This will be different, again, for the source. So the data set that you're getting here is primarily from the perspective of this guy. The data you get about all of the transit nodes and the destination is coming from that source in your network.
Okay, so what kind of rights are required then at that agent? Do you have to then provide credentials out to your service in the cloud? Or how?
So you saw me deploy a service here, and maybe it would help if we took a look at that. Just broken, great. Let's see. So this is a lab toy. You can expect visual anomalies and bugs as we go along here, and maybe a crash or two. But you saw me just deploy this service to Thwack. The source is the same, and the destination over to Thwack. Seem to be having some trouble there. But you saw what I put in. The agent was deployed on the source all the way on the left. Everything else is derived from probing.
Okay.
But you didn't have to log in to use that service or anything like that? I mean,
no.
So if
We-
there
we
was a
just
service
created
that you
it.
had to log in, like Salesforce or something like that, you still wouldn't have to provide credentials for that? I mean, that's what you're asking, right?
That is what I'm asking, yeah.
Right, so if you take an application and divide it up, there are several network paths that are important. The first front-end facing one from the user to the service will source from the service and go to some destination port, generally a TCP port depending on the service. So even if encryption is used or logins or any of these security mechanisms, the TCP conversation needs to happen, and that's what we're testing against.
So you can go. So what you're saying is you can span the paywall or the login blockage or anything like that just by doing a TCP transaction effectively, not actually trying to read a page or something like that.
Right, we're not really interacting with the application.
You're just doing a TCP probe.
It's
thing,
all TCP based.
kind of thing.
So how does that work from a security perspective then? I mean, I guess it depends on what you're pulling, but it feels like you could be transmitting potentially, I don't know, information you wouldn't want to be back to your product.
There's not a lot of. I'm struggling to think of anything that would be private. I mean, you're dealing with probe traffic, which you don't care if anyone sees. You're not putting any credentials.
It's like you're playing like a denial of service attack, only you're not actually doing a denial of service attack. You're just doing, occasional once-a-minute probes or something like that.
Yeah.
So, but to continue from that though, that would look, the traffic from that would look, from me, on the other side of the internet, that kind of probing traffic would look an awful lot like someone sniffing around trying to find potential intrusion points. So, could it,
Well, sniffing usually relates to mini ports,
Yeah.
right? So we're just looking at the application port. We're very targeted, and there's some service running on that. So we're going to start the TCP conversation. We are very cognizant that the more traffic we send toward that, the more potential there is for impact. So we try and minimize that traffic. It's also notable that not every packet that we send makes it all the way to the destination. So there's a limited impact to each node along the way and each endpoint destination.
Agreed. I understand that. So the stuff along the way, for example, is just networking stuff that's there. So and they're constantly being probed by everybody. So this traffic would look like everyone else who's scanned. It would be difficult for someone who is not familiar with you or doesn't have a direct relationship with, say I'm using this. I have a commercial relationship with the endpoint, and I'm trying to monitor that service in some way. But I'm doing it in I'm going to monitor your service, not I'm going to connect to some status information with and log into my account from
Right.
you. So it's a different relationship.
Definitely different.
So they could potentially identify my traffic as being as potentially malicious, even though it's like if hackers these days are much smarter than just doing a massive Nmap spray. I mean, even Nmap will try to slow things down and random offsets and everything else. So it can kind of make the CISO's job at the remote site more difficult, is interesting. But also all the way along the traffic path, it's similar traffic to what anyone else would be probing.
Right.
So it's an interesting thing. It's a difficult needle for you to thread.
It's a new technology. We're still playing with it, and iteration is required.
Yep.
But what we are very cognizant of the potential impact and security implications, and we're building it with that in mind. We've had pretty good results so far.
The originating point, though, as an idea. So this is that the customer site. So I purchased this service from you or this software from you, and it originates from the customer's site to monitor the full length. Is that right?
Wherever you can deploy to a Windows device that has 443 access back to your central location.
Yep. And the way, because you want to trace the path from them to the destination, it wouldn't be possible for you to have, say, a probe that lives on the internet from a known address, so you are a known good actor, a little bit like mail houses that are known to not spam people. you develop reputation with some of the services that get monitored, and you monitor on behalf of customers.
You know, that may be required at some point. We're not really seeing a lot of issues yet. Like we're seeing great visibility, no complaints. We have contacts with some of these ISPs, and it's working.
Okay.
Okay, so moving on a little bit. So we've explored the transit here a little bit. We've seen one of these problems. So the next thing I want to talk about is once you get your bearings, you'll want to start understanding the problem, start isolating the problem. And if I wouldn't minimize my screen here, we could do that. So the way that you isolate the problem, or the way that this attempts to do that, is we quantify the performance impact of each individual link and node in this critical path, this total path that's delivering the service, and then correlate that to the end-to-end performance. In other words, this device right here, right, owned by Exo Communications, has 4 incoming links. And if we look at those links, we can see that most of our traffic, 48%, is flowing through this is the link carrying the most traffic, rather. 48% is flowing through this link, and this link has by itself a performance impact of 30 milliseconds and 0% loss. You can do that for each one of these links separately. And of course, each one of the nodes also has performance characteristics tracked. So with this sort of base layer of information, then you can start correlating, right? So if this has 48% of your traffic and it introduces 50 milliseconds as compared to this link, which has 34% of your traffic, introduces 41 milliseconds, and the end-to-end latency is 20 milliseconds. I'm making those numbers up. So it would have to be maybe 200 milliseconds. Then you get an idea of the relationship between all of your connecting nodes and edges and the endpoint service you're providing.
And the probe interval is once a minute or something like that, or?
The one I configured there's 5 minutes. I think we allow between 1 minute and 2 hours.
Mm-hmm. And the statistics about node and or path latency, are those available in like an Excel spreadsheet that can be looked at more detail, or is it just summarized?
It's summarized. We have been talking about whether we want to expose it. I mean, it's a lab toy, so for us, we do have a debug mode that shows all of that data. We've been talking about whether we want that exposed in the UI, really. What it amounts to is...
From a statistical perspective, I'd like to see the variance, not just min-max and median versus average kind of things, but...
Yeah, I mean, it depends on what our goal is, right? There's a lot of data we're generating, and we can just produce tables and tables of data. Our goal really is that someone who is not necessarily an expert in global routing and BGP and peering and all of these things can, within a couple of minutes, get to this screen, see red, where we have identified that thing is red, and then start to take further action in that red area.
And red in your instance indicates that not that the node is down, but the node is performing extremely poorly compared to the other nodes and paths on the
For both.
So
data flow, I guess.
one of the red has the finding of the multipath was an interesting challenge for us to solve. The quantifying the performance of each of these nodes and hops was an interesting problem for us to solve. We thought those were the big problems. What we found is in our in the way that we choose to deliver value, we try and summarize data to a red, yellow, green status.
Yeah.
That turned out to be the biggest challenge of them all. So if you consider that we're focused on the end-to-end service, then the only way you should, for example, paint that node as red is if that node is causing a significant impact to the end-to-end service. So you have to look at its latency, the latency and packet loss it introduces, and how that relates to the end-to-end service, keeping in mind that only a portion of your traffic is going through that node.
So are you correlating all this back to the applications themselves as well? So I don't have to just look at this view? To where I could look at my application, my web application running in the cloud or whatever, and I know that it's not performing well, and then I can start drilling down to this view, but not start here.
That's something we have in mind for the future. We haven't even started on that now.
Oh, okay.
So you said, you're collecting tables and tables of data, or lots of data, and
Lots of data.
to me that's a wonderful thing. So and also
Well, this is SQL. You can have as much as you
yeah,
want.
oh thank you. So but that's my question. So as much as I also love models, usually these graphical interfaces, which again I love, this would be perfect for me, someone like you said who doesn't have all the skills to just pop open a command line and just go start asking questions in Klingon. So is there another view of this same sort of thing that I might, like we mentioned spreadsheets, but I would go further and bring it into some sort of analytics and therefore maybe do statistical analysis on, has this always been a problem? Do we normally hit this problem on Fridays or Good Friday?
Yeah, so we'll get into a little bit more of the changing coming up next. It's interesting because I'm hearing from this side of the room deeper data, hearing from this side of the room like more high-level data.
I need the data. Yes, thank
want
you
both.
for saying that.
That's it.
Want it
It
all.
was like the
Okay.
two whiteboards.
We want it all.
But that's why I want the data, so I can
want
ask
it
it
all.
questions, which I think is the same thing, right?
Well, there's lots of stuff we don't do yet.
Yeah.
Let's take a look at a little bit more that we do. Okay, so we've we've discovered our network. We've got our bearings for what devices are important for delivering this service. We've seen how problem isolation works. The next step after that is to take action. So there's two pivots there. What you generally see is the front portion of the path is your gear. In this case, for your gear, for gear that you have administrative privilege to, we can start pulling in all of the data we have. We happen to have a lot of data about our customers' gear here at SolarWinds, right? We've been building out that data set for over a decade. So we can pull in things like CPU, RAM, which interfaces are participating in the transit, what's their error rate, what's their bandwidth rate, when has there been configuration changes, all of this wealth of information that we have about your gear. So that's one pivot if you're seeing red in your area. The second option there, or the second potentiality, is that you will see red at some provider's network, some gear that you don't own. So here we go and pull, we can tell you who owns that gear, so who's responsible for that, tell you a little bit about how they route that, what prefix they're routing, how they're originating it from, or where they're originating it from, then provide you with a phone number.
Provide for latency and packet loss are specific to this user to application flow, or just from the network node itself, providing you generic statistics for its activity?
This is focused on the problem, so this is from the source.
So this is from your probes.
Yeah.
And I need to look at this from a WAN perspective, right, versus an internal.
That's an interesting question. I'll show you the Lan Perspective soon.
Okay.
I think it's applicable
Just
to
real
both.
quick, on Ray's point there, the network nodes are not providing you statistics per se, are they? You're just probing and taking feedback and making your own mind up how many.
Because we have no administrative access.
Yeah.
Yep. Okay, so there's a phone number and probably an email address here. So the goal is find out who's responsible, find out their contact information, and have precise, actionable information about their network that generally you don't have. So you could, for example, say to them, you have a node, it's one of your backbone nodes.
Notice when you select that node, it's sort of giving you indication of what other nodes are also owned by the same entity. Is that what you put those other blue? No, go back to select the node. You notice how the blue boxes are put on the two nodes in front of that?
Right.
Are they? Is that because that's also owned by Time Warner Cable Internet?
There's two animations going on there that kind of overlap. When you hover over the name of the network, you see all the nodes participating in that network. And that's how the summary function works as well. So I can take these XO communications and
Metadata.
dump them down, dump these guys down. So I can view it from the perspective of what companies am I going through, right?
I got you.
So jumping again, so that's basically how, so the story was that you need to call one of these people, you have a problem in their domain, you would call them, you have their phone number here, and say something like, you have node DFW10, here's the IP address, it looks like it's your AE1 interface, and that's connected to your other node, and that's your Ether 12. From those two places, you have a specific behavior and when it started, right? So that's the action for the cloud side.
So you get historical data out of this somehow as well.
Yeah, we'll take a look at that very, very shortly here.
So are you going to add in actionable items from this where I can automatically open a ticket with XO if a specific threshold is met?
It's
versus
an
somebody-
interesting idea. I haven't really thought about that.
Because, I mean, for me, I mean, we use XO, but
Yeah.
they're notorious for problems, right?
I've heard ISPs have problems.
It would even be better, right? If you could do it
If
that
I don't
way.
have to
If you
call
could-
them.
Yeah, because if 100,000 of people are going to use your application and you're all going to call them at
Exactly.
one point because one of their applications has a problem.
So, setting aside some privacy concerns for the sake of nerd theory, if we had this deployed in many environments with many customers, then it would be a really interesting data set to pull things like which ISPs are more reliable or usually source problems, which ISPs transit fastest. If 90% of people using this are having a problem with one ISP, should we call them? Should we call the ISP? So there's some interesting stuff there, but I don't know what we would do about the privacy. So right now, what you see is what you get.
No, that's cool with that.
Question.
So you asked about time. So you guys may have seen at the bottom here, we have this availability timeline. That's let's pump that up. And it doesn't function because this is a interim build. Let's try refreshing. So at the bottom here, we list latency that we're getting. This is end-to-end latency. This also becomes your navigation function. So here's looks like an interesting thing that was happening. So let's take a look at right here. We bumped from 21 milliseconds to 107. So clicking on this gets us to the transit path during that period. That actually does look different. Let's look at right before that. We were 21 milliseconds. Okay, so something happened in the back half of the path here. We were transiting through our own network, just peering with the internet, Time Warner's other autonomous system, XO, communications, and Quest, and reaching there in 21 milliseconds. We jump to the other guy and we can see Time Warner then, our traffic for that service delivery moved to Tata Communications. Tata Communications also has Akamai nodes directly in their network, right? Because it's a CDN. Looks like most of our traffic is carried through this top link, 98%, and 67 milliseconds. So that's a lot of new injected latency here. So we can start to pull apart not only what routing change occurred, but who is involved and what the end-to-end performance impact is and what the nodes and links were that caused that end-to-end performance impact.
So in this design, who or where is the SQL data? Is that something you're holding, or is that something I, as the customer, keep in a SQL database on site?
So it's like a toy in our lab, so it's on a SQL database in our lab. How that would be deployed in production environment, don't know yet. Okay, so one last thing I'll leave you with if I have time.
Are you going to show the LAN stuff?
Yes, is the LAN stuff. So I geeked out a little bit on a GNS3 environment, so let me explain this for a very short period. So here we've got a GNS3, we've got a host, and that's actually a Parallels VM running here.
Hey, I don't know what GNS3 is.
You don't know what
Emulator.
GNS3 is? No, GNS3 is a network simulator,
All right. Okay.
network emulator to be technically accurate,
Oh, no.
where it emulates routers and so forth. Okay, so we've got this host running on a Parallels VM that's connected to a GNS3 router. That's a 7200, Cisco 7200. That connects through a couple of other routers over to this destination. We're going to be showing transit from the source to the destination, hoping it works. We've also have a WAN emulator here, so we can inject latency, packet loss, other bad characteristics, jitter, that a WAN may have and see what the result is. So let's take a look at that in NetPath. If I can find it here. So the first thing to note here, we built this path in NetPath the same way you saw me build the first one. Source, destination, port, and that's it. The picture that we came up with looks pretty similar, so hopefully that actually looks like your network. So we're sourcing from this host, going to this R6, and you can see the alignment there.
You really want to make this thing a web tool that anybody can access for free to do, a certain, path trace. This is a very sophisticated tool. I've had problems with networking services in the past where it's just no way I could understand what's going on and stuff like that. And if I had access to something like that as something I wouldn't even have to license for, but just utilize, I'd just be amazed. I mean, it would be a good on-ramp for your product. It would be just amazing.
So this is not a trivial amount of compute that is required to run this, or a trivial amount of packets. So the idea that we would host the service and give everyone the access to build paths at will would be probably prohibitively expensive, but we are thinking about what is a simpler way to access this, almost traceroute-esque, where you solve that traceroute problem, but without all the caveats of traceroute being blocked through firewalls, not doing multipath, all of these things. So it's an interesting idea we're thinking about. Okay, so looking at this network, see if I can find. So what I did is I had this network running, testing between these two nodes, and then I injected latency right here. So that happened at this time interval 634. So this 632 is right before that. We'll move forward. We see the latency go up. There's no alarms. Keep moving forward. And we get to our alarm state. And we focus in on the problem. So when you inject latency right here.
The challenge I have with having that availability timeline on the bottom is that it at first I thought you were talking that was somehow mapped to the nodes above it, but in reality it's a histogram of all the activity across those nodes. You know what I mean? So the availability underneath it, right, is showing a histogram effectively of all the path activity across all those nodes. So any one of those blocks is a transaction that goes from user to service, right?
Right. It's focused on that user to service health and performance.
I almost want to have the availability be vertical rather than horizontal, because I keep thinking that that's showing me the activity on a per path basis.
So you're relating that this connects to sort of this and this connects to this?
Yeah, that's what I'm.
Okay, that's an interesting thought.
Okay, so I'm going to throw one more thing out.
I'm sorry.
Just the visual representation.
Again, it's probably not available now, but
No.
the idea of
trying to
correlating
summarize
these
what you're
events
saying,
back
so I
to
understand what
syslog, because with your syslog
I
collectors,
think you're right. It would be more.
is that something you're going to be doing over time as well, or do you already do that?
That sounds very interesting. So now that let's actually jump over to that. So we've seen where we implement some bad WAN behavior, and we see
Can I interrupt for a second? I did not hear that question.
So where I'm going with this is being able to see these blocks of events that are occurring. If I can correlate that to my syslog collectors, which coming from my load balancers or whatever might be in the path, I can start correlating what occurred where to help me track down where the issue is, and start seeing, was it actually the WAN trigger, like Justin was talking about, that triggered my IDS to go off and start causing other downward effects, but be able to see that complete path along with details from syslog.
Okay, thank you.
Or Windows events or anything like that may be in.
Yeah, cross-system correlation is really handy.
Absolutely.
So now that we've isolated this problem, let's move forward a little bit. Let me see if I can get at that data. To be honest, I don't know if I can. Kind of fly here. Doesn't look good. I'll try one more spot. Another interim build. It's another box in our lab environment that's being used.
I like that.
Hey, while you're doing that, you said you work in the networking group, yeah?
Yes.
Yeah. Do you have like a feel for like whether the network is almost always the problem? No, I mean, because you got this super awesome tool, right? And the network guys say it's never the network, but everybody else says it's like always the network.
That's what I always
So
This is what
I'm
helps
kind
them prove
of
it's not the network. is what it
interested
is.
in the truth from you.
Yeah, I'm not sure I want to comment on that one.
We know what that
Man.
means.
I think I'll
So
definitely
is the
make
network
enemies
not-
somewhere,
Throw that
regardless.
disclaimer back up.
No, people aren't saying it's the network admin's fault. It's
No,
the network's
never.
fault.
Absolutely, yeah.
No, we're saying it's the network admin.
There's a blog post about that. Yeah.
It's never a storage admin problem.
So,
Are there any storage admins anymore?
All on the
Hold
cloud
on,
now.
yeah.
Talk.
So there's a lot of data that we could pull in. We're just starting to fiddle with that now. This is a poor example, but it's the best one I have in a live working machine for you guys right now. So we have our latency and packet loss again from the source to the destination, and then we start pulling in interface information, CPU and RAM, all 0 because it's not functioning right now. But we're really trying to bring in all of the wealth of data that we have about your environment into this one picture. Now that's a lot of data, so how we focus that data is production impact. I don't want to know about my third power supply out in a 3 power supply system. I don't, if the first 2 are fine, there's no production. Find out where there's production impact, that's the job of NetPath. Then pull infrastructure data in to support and sort of dig down into why that production impact may be occurring. That's pretty much all I have. We want to do Q&A.
When you're hovering on the endpoints, you're getting an end-to-end view of latency and packet loss, or just that node's view?
So here's how we've chosen to visualize this now. I don't know if it's the right way, but whenever you click on a node, or here, you're getting the information from the source all the way to the node, right? So you can see that building.
Source
as you
all
move.
the way to the node.
Source all the way to
So
the
it's
node.
cumulative.
Cumulative here.
Oh, I didn't
When you look at the interfaces, or rather the links, then you get the diff data, right? So this is 2 milliseconds for that specific link, and then there's packet loss for that.
Cool, so very helpful information.
So you could also drive automation out of this too, from your WAN connections. You have multiple paths or whatever. You redirect traffic.
If it's emitting the information. So,
exactly.
and that's a question, I suppose. There's 2 parts. One, can I poll this information using some sort of REST API? And secondly, when something changes, like when it notices that, an event has occurred and the path has changed, or this link is not performing and so on, does it emit some kind of message that I could then collect with, say, Orion or some other tool that I can then use to do the cross-correlation between systems?
And then
Yes,
other
so-
events to occur after that.
So there's no REST API access to this now. Being a lab tool, we didn't think that was super important for our lab.
Which is fair.
Yeah.
We in terms of alerting, I can tell you 2 things. One is we like alerting here. We think it's really valuable. We've spent a little bit of effort on it. But what I will tell you is we think the important thing here is the user's access to the service. So the entry point for alerting, how we see it, is from the end-to-end performance tells you about a degradation for the user service, and then that pulls you into here where you would look at the individual nodes.
Which is fine, because now I'm in network context. I'm looking at this particular thing. But if I'm looking at a different scope, a larger scope of cross things. So the example we had before, I can correlate between a change was made over here, and then 30 seconds later, performance went down. So now I can sort of go, instead of saying, looking in this context and figuring out, okay, something's gone wrong and it's with that network interface, now I know where to go look. I'm already looking up here. So that with this, it would be great, because I could be able to see, like you had before, hang on, my route path changed, it's now all flowing via a different ISP.
Yep.
Maybe I have some other information over here of saying, oh yeah, we're doing some work on something or other. Great, that explains it, it's no big deal. Or, that's funny, I need to go figure that out a bit more.
It's an interesting idea. I think, I don't know exactly what that would look like. What I can tell you is we've just been focusing on getting the data available and working in the first place.
Okay.
Yeah, interesting idea. Any other questions before I let Stephen?
Very cool tool. Please make it.
Yes.
Yes.
Yeah.
It is
Okay.
very cool.
We'll
there's
keep
a lot of
working on it.
potential for sure.
Yeah, okay. Shout out to our lead developer, Lan, and our lead front-end developer, Rick. I actually don't build
Are you
anything.
kidding me? His name is Lan.
Lan. That's why we chose him. We hired him for that. Lan.
we love
Lan and Rick.